Okay, so this video is about using trig functions to find angle measurements. So we have to remember still the basis that our sine of theta is equal to opposite over hypotenuse, the cosine of theta is equal to adjacent over hypotenuse, and that the tangent of theta is equal to opposite over adjacent. We also have to understand that trig functions have inverses, have opposites, just like the opposite of addition is subtraction, the opposite of multiplication is division, the opposite of squaring is taking the square root. So if I'm looking for the angle, if I'm looking for the theta, and I know what x is, then I need to switch the two. I need to find the inverse. So to find theta, I'm going to have to use the inverse function. So I would have to find the inverse of x would equal to theta. When I read that, it's read as the inverse sine of x. For the cosine, I would do the same thing. I would flip these two, and it would be the inverse cosine of x is equal to theta. For the tangent, to flip these two, it would be the inverse tangent of x is equal to theta. And this is a button on your calculator. Usually for most calculators, you're going to hit the second sine to give you the inverse sine, the second cosine to give you the inverse cosine, and the second tangent to give you the inverse tangent. And these are the functions that we use when we're looking for just the angle, for when we're looking for theta itself. If I'm looking for the side, then I would not use the inverse function. Okay, so like for all of the other problems, I'm going to start by figuring out which angle we're talking about. So the indicated angle is almost always my theta, and I'm going to label the function, or label rather the triangle, with opposite, adjacent, and hypotenuse. So in this case, 18 is my adjacent, 23 is my hypotenuse. Which trig function deals with the adjacent and the hypotenuse? Well, that's the cosine. So the cosine of theta is equal to the adjacent over the hypotenuse. So I know what 18 over 23 is, but I want to know what theta is. So I'm going to have to swap these two and do the inverse cosine of 18 over 23. And that's going to give me my theta. So in my calculator, I'm going to do the inverse cosine of 18 over 23, and I'm going to get 38.5 degrees. Again, make sure that you are in degree mode. If you're in radian mode, you're going to get something different, and it's going to give you the wrong answer. For my next problem, I have, that number's 5 right there. I kind of cut it off. I'm going to go ahead and label my triangle with opposite, adjacent, and hypotenuse. So 5 is the opposite, 21 is the hypotenuse, and if I look, I find that the sine is the opposite over the hypotenuse. So the sine of theta is equal to the opposite over the hypotenuse. I want to know what theta is, so I need to switch these two. In order to switch them, I have to do the inverse of 5 over 21 is equal to theta. Put this in my calculator, and I get theta is equal to 13.8 degrees. Next problem. Again, we're going to identify my triangle with opposite, adjacent, and hypotenuse. This one's opposite and adjacent. And if I look, opposite and adjacent is my tangent. So the tangent of theta is equal to 17 over 18. Do the inverse function. So the inverse tangent of 17 over 18 is equal to theta. So in this case, my theta is equal to 43.4 degrees. Yes, you need the degree symbol. Without the degree symbol, then it's actually in radian mode. And we're not finding radians, we're finding degrees. Next, label the triangle with opposite and adjacent hypotenuse. 39 is my opposite, 20 is my adjacent. So this is also the tangent. So the tangent of theta is equal to 20 over 39. Flip the 2, and I get the inverse tangent of 20 over 39 is equal to theta. So theta is equal to 62.9 degrees. 2 more. So opposite and hypotenuse, which is my sine function. So the sine of theta is equal to my opposite over my hypotenuse. Do the inverse function. So the inverse of 29 over 52 tells me that my theta is equal to 33.9 degrees. And last, but certainly not least, we have adjacent and hypotenuse, which is my cosine. So the cosine of theta is equal to 12 over 19. Inverse cosine of 12 over 19 is equal to theta. So theta is equal to 50.8 degrees. Okay, so I know that was pretty quick, but that's how we use trig to find my degrees. We have to use the inverse function to find the degrees. Good luck.